Okay, so welcome to the panel on next generation robotics. Our three panelists work at the intersection of AI, machine learning, and robotics. And I'll ask you to first introduce yourself. Do you want to come in closer or not? It's okay? All right, thanks. So I'll ask you to first introduce yourself and your research area, and let's start with Angela.
Hi everyone. Is this on? Can you hear me? Okay, yes. Hello everyone, my name is Schoellig. I'm a professor in aerospace engineering at the University of Toronto and affiliated with the Vector Institute. My research is at the intersection of robotics, machine learning, and control theory. And really we are motivated to enhance the capabilities of robots and enable them to operate in more complex environments. And so if you come to my lab, you see robots moving. You see flying vehicles, self-driving vehicles, mobile manipulators. And so that keeps us really grounded and realistic, and also allows us to discover really serious open problems in robot learning, and we try to address those. So for example, how can we guarantee a robot learns in the real world but does so safely? How can we make robot learning more data efficient? How do we deal with the different time scales of fast adaptation and long-term learning? And so these are kind of the problems that we are interested in. And I guess more recently also, how do we do learning more efficiently in interactive tasks?
Thank you. Rupam?
Yeah, I'm Rupam Mahmood. I recently joined the University of Alberta and Amii. Is it working? No. Oh. Maybe. Hello? Are you the other one? Can you hear me? Oh, great. Yeah, so I joined University of Alberta and Amii. My background is in reinforcement learning. So I did my PhD in RL. And I was always deeply passionate about creating tangible intelligent systems. So after I was done with my PhD, I joined a Canadian robotics startup called Kindred. And there I gained experience on how to build learning systems that can be deployed to a robot to solve a closed-loop control task using real-time interactions, as opposed to learning from simulations or learning from human demonstrations. So after that, now I'm back to academia. So now my long-term goal is to develop general and constructive mechanisms for continually improving robot minds. So one way to talk about generality is think about it like ourselves. We are different people. We have different emotions and different memories. And we also differ from other animals. So are we different because we have different mechanisms for processing information, or because we have different past experience and past evolutionary history? So it would be lovely if we could explain ourselves in terms of only a few set of mechanisms, and we differ only because of our past experience and evolution. So I don't want to get too controversial, but to talk about generality is much easier when we talk about robots. So here, my goal is to develop a single system that I can deploy on different robots to solve different tasks, as opposed to focusing on one particular robot and transferring my understanding to the robot. That's my research goal. Yeah.
Thank you. Animesh?
Hello everyone, I am Animesh Garg. I started as faculty in computer science at University of Toronto and also at Vector Institute. A lot of the work that I do corresponds manipulation, robot manipulation. To be precise, and the driving question is the computational underpinnings of decision making in dexterous motor control. In other words, what are the technical questions that still need to be answered for us to be able to build, let's say, a robot that can achieve the dexterity of a 7-year-old child. That requires a variety of technical problems that are across fields, from reinforcement learning, imitation learning, where the regular questions or the off-cited problems of efficiency, transfer, off-policiness, all of those come up. the other set of problems that actually come up in building robot manipulation or robot manipulators is also the ability to handle perceptual input. It can be vision, haptics, and how do you handle and represent these inputs in a manner that is fairly general, domain independent, and yet useful. And finally, a lot of the problems intersect with core problems in machine learning, where an often cited debate is, should we be using models, should we not be using models? If we are using models, then what sort of functional approximators should we be using? How to combine these ideas with generative models, causality. And these sort of form the pillars of what I would call algorithmic research. But as in robotics, as Angela pointed out, a lot of the things are also have to be grounded in reality. You really have to build it. If it doesn't work, it's really not a robot. So I work in domains such as personal robots and surgical robotics, where the idea is to build infrastructure that needs to work not in 50 years, but hopefully in 10. And that involves building or putting together components that come from both machine learning, computer vision, perhaps reinforcement learning, and other ideas in decision making into a singular system that needs to perform at certain levels. And it also gives us problems, newer problems, to solve in these domains.
Thanks. So when I looked at your CVs and your web pages in preparation, it was clear to me that you all could be anywhere in the world. So I'll ask you the CIFAR question. Let me start with Rupam. So why Canada, and then why is the particular AI Institute where you are? Why is that the right place for you rather than somewhere else in the world?
So I believe that build understanding around mind and intelligence, and to have a career in AI, we need to have long-term vision. And I'm continually impressed by the commitment of Canada to long-term things, such as like the desire to have clean environment or a healthy society. And I think that the pan-Canadian AI strategy it's not a new thing. It's part of that vision. And that attracted me. And University of Alberta and Amii, they're part of that vision, I would say. Especially, let's look at the motto of University of Alberta: whatsoever things are true. Right? So the commitment to true naturally would lead us to care about long-term things. And Amii also embodies that. And that's what attracted me. It helps me think deeply.
Thanks. Angela?
Yeah, I think we all know that we don't do research in isolation. So the environment matters a lot. And that means colleagues, students, the funding environment. And so I think that was just very attractive at the University of Toronto. There's, clear excellence in machine learning, but also in control theory. And it's a really leading institution in field robotics. So that was quite exciting. I also love the breadth of the university because robotics ultimately can impact many different application areas. So seeing the breadth within the university is really nice.
Animesh?
I think to add to both of those points, and this has been repeated since the morning, of course, the ability to do longer-term research was one of the things, but I think one of the new things maybe, in addition to these, was the number of young, vibrant colleagues was exceptional. It was not present in any other place I interviewed. All of these people were extremely excited about what they did, and it was a very diverse set of things that they did. So that's one thing. And then all of them being leaders in what they do, you put them in the same room, that creates an environment that is also unparalleled. So it's very easy to go and talk to people without sending them emails to meet next Thursday. That changes the dynamic of how things work. And now put all of that together with the ability to attract world-class talent. That is yet another sort of what I would call research needs to be done not with just colleagues, but also students and postdocs, and we need to be able to attract them, and that helped. Vector helped here. And now put all of that in extremely cool city. So it's unparalleled in that sense.
He's referring to Toronto in case. Yes. Animesh, you mentioned students. Let me pursue that a little further. So, but the three of you are all three of you are fairly recent PhD grads. So, what advice would you give to students in your field? And maybe you could elaborate and talk about best practices. What did you learn from your supervisor? What will you pass along to your students? And maybe specific to your field or just in general? Do you want to start, Animesh?
Sure. One of the things I noted, and this is something that has become one of the things I tell all of the students I work with is, pick a problem. It may be hard to find what you want to work on because there are so many things to do and so many cool things to do. But once you pick a problem, stick to it. Do not switch. Often the first paper will be easy. These students are very smart. Getting the first paper will be almost always easy. It's the second and the third paper that would be harder. And it's almost always that the first time a student works on the first paper, that will not be the earth-shattering result. You'll probably want to keep working on the same problem for at least 2 or 3 years before something interesting happens. And in the current climate, it's very easy to keep sort of checking off the publication list by keep switching areas because there's enough sort of hot topics. And that doesn't really help much. So stick to it. Stick to one problem and don't always chase the hot topic unless you're going to stick to it.
So build a reputation in a specific subfield.
Not just reputation, you don't yourself understand the problem unless you've written 3 papers about this thing.
Right, build the depth of knowledge.
Yeah.
That's good. Rupam, would you like to?
Yeah, so what I learned from my supervisor, and I want to pass it along, which is that the students, they should think about what will be their role in the future of AI. Right? So there are so many things that are happening, but there are also some problems that are long-standing, and they do not get solved even by the most advanced deep reinforcement learning algorithms. And there are so many of them. And rather to focus on them than, say, being distracted by easy success. That would be something I would advise.
Okay. I think mine goes a little bit in this direction, and I think I really encourage students to ask their own questions, because very often the longer you work in a certain field, the more you are influenced by the current trends and directions. But I think especially as young grad students, learning about the topics, you really come across these potentially obvious questions why things are not yet tackled or have not been solved. And so, asking your own questions, I think, is really important. And then also I really try to encourage students to be honest and really discuss the advantages but also limitations of their work, because only if we are honest about the limitations, we can make progress in the future.
Thanks. So as far as I understand, all three of you are full-time academics, correct? And how did you choose whether to go into industry or the academic world? Why did you choose the way you did? Who would like to start? Do you have any thoughts? Angela, could I pick on you to start?
Yes, so mine was kind of a coincidence in the sense that I never made up my mind about joining industry or academia, but then the academic job came faster than I could even apply for industry. So that's kind of how it happened. But I really enjoy, I guess, the freedom of collaborating with people I like to collaborate with and answering questions that I think is exciting. But I do think, there's so much interesting things happening on the industry side, and the trends that we see that people flow back and forth, I think is very good ultimately for our progress.
Thanks. Animesh, would you like to go?
For full disclosure, I still spend some time at NVIDIA, so it's not completely one side. But I think the decision was, as a junior researcher, I really like to be able to work on a research vision. Sometimes that requires a team, sometimes that requires you to think beyond just, say, 1 or 2 or 3 years, and also not just working on 1 or 2 projects. That was something that was only afforded as an opportunity to me at the university rather than, let's say, at any of the companies Perhaps if you have a 100% team, a deep mind, yes, you could probably execute the vision there as well. At the same time, in the last few years, we have seen that equally good research and perhaps sometimes exciting research is happening on either end of the spectrum. So it's not necessarily better, it's just a career choice, I think.
Yes.
Yeah.
Rupam?
Yeah, so I came back from industry, so I feel like both are important, and I still see the value of having both. For example, in the industry, when I worked at Kindred, I worked on something by which all of us at Kindred got benefited by a lot. For example, Kindred, the production team, they got a technology, a powerful technology that essentially changed their game for their production robot. On the other hand, I obtained a lot of problems to solve, right? So now they're focusing more on utilizing that technology for their production robot, whereas I am now utilizing the problems that I gained and trying to solve them in the academia. So I think this back and forth, or at least having a direct line with the industry, or keeping in touch with it, is quite valuable.
Thanks. So I think we all agree that the AI, machine learning, robotics has incredible promise, right, for society, and is happening now, right now, and also perhaps a lot of peril for society. So if I could ask each of you, what would you not want to see, if you're willing to say it, in the next 5 years? I'm not asking you to really make a prediction, but just what would you be uncomfortable with, where your field would go, what kind of applications, and then to keep it positive after that, what would you like to see? What do you hope to see in 5 years that will benefit society, broadly speaking? Who would like to go first?
Okay, I can go first. Robotics in the current setup, a lot of the times, the way market forces work, or the way it is being developed, or at least the motivations for such development, can often be, whether implicit or explicit, designed for job displacement, especially at the lowest rung of the jobs. That would be kind of a societally bad decision. And on the upside, there are certain areas where human augmentation would be a very good idea, and human augmentation in both cognitive and physical sense. So certain jobs are indeed actually treacherous, or just like should not be done by humans. They are being done by humans just because there's other ones that are existing and need to get done. So of course there are more high-tech versions of these things where this is surgery and surgeons, but also sanitation work or mining, and often even at this point stuff that is warehouse fulfillment. All of this is not necessarily the best of the jobs. Mm-hmm. And it's worthwhile to work on technology to replace those things.
Thanks.
Yeah, so I want to address a little bit on the job displacement thing. So Kindred, they have a production robot, and it is deployed in the warehouses of, say, the Gap, the apparel company, and their warehouses are in the middle of US. And what happens there is that, like, during the peak season, they don't actually have enough people to work. And by having these robots, so that's coming from Gap, they're saying that they still have this shortage of labor problem, but the few people they have, they become more productive by working together with robots. So oftentimes it is actually not quite the way we think, that it will totally replace job. And the thing that I wouldn't want to see after 5 years is that what we are seeing today in the robotics industry, which is the industry in the robotics industry, companies, they focus typically on one particular robot, and they try to solve one task. And if you set up, like if you have a startup for that, it will take like years to build an engineering team and the platform to begin your production. And if we continue doing that, so that's not good. We want some scalable technology so that a company can easily move around different applications. And each time it wouldn't take like years to build a team. So that's one thing. So what I would want to see instead is from a reinforcement learning community, we'll have enough demonstrations directly applied to robots for learning in real time, so that the robot manufacturers, they get inspired to rebuild their infrastructure so that their software and hardware, they are compatible to learning, so that their hardware can be used for exploration, and their software, like the default controller they provide, I hope that that includes some pre-learned reflexes or some features which can be further modified or learned with more experience. So that's what I would like to see in 5 years.
Thanks. Angela?
I think I start with what I want to see in 5 years. So I'd like to see more robots in our human-centric environments. So right now, the majority of robots are still in kind of factory environments. And so doing a next step in getting robots closer to us and helping us. I mean, self-driving cars is one direction, but any kind of a mobile manipulation in less structured environments. And I guess the danger is that we go too fast in robotics, because then, robots ultimately are machines that physically interact with the world, so they can also make bigger harm than other machine learning systems. So I think we just have to be careful to not, destroy the progress by having failures that are too traumatic, such that the research field will be harmed.
Thanks. So my timer says that I've used up more time than I was supposed to, but let me open it up for some questions from you, the audience, before we break for lunch. So that was sort of an incentive there to ask your questions. Are there any questions? Or you all want to have lunch now, I guess. That was a mistake on my part. Okay, I should have planted a question and I didn't. Yes, okay. So before I break, I just want to put in a plug for Angela's website. She has these great videos on YouTube that you can look at, so please do that. And let's thank our panelists.